All right. All right, let's get started. Who's ready for this? Me. Oh, who's ready for CSE116 in the summer? The hub logged me out, but I like double checking to make sure I have the right time. I have the right time. All right, so let's get started. CC116 in the summer. Let's do this. The big thing I'm going to repeat early and often, it was already the first thing that I said in the email that I sent out, is the summer session goes very, very fast. Every lecture is effectively a whole week's worth of content in the fall and spring semesters. So every single lecture is a lot of content, and and it goes quick. 2 lectures per week, so it's just a lot that will come at you very fast. Do not fall behind. Students who fall behind in the summer will often fail. I don't like seeing students fail. I want to see you all succeed. And falling behind is the number one reason why a student is going to fail in the summer course. So staying up to date on absolutely everything is very critical. There are 2 lectures this semester. A lot of this I said in the email, so I don't want to repeat a lot of it because we got to get to the content pretty quick. But there are 2 lectures, one at 8 to 10:30, and then this one from 11 to 1:30, that you can watch either one of those or both of them, or watch the VODs. If you don't watch them live, I don't take attendance or do lecture questions or anything during lectures. The only reason I do that is because some of you are in time zones where you're naturally asleep during both lectures. I don't expect you to wake up in the middle of the night to watch the lectures. If that describes you, just get your sleep, wake up, and then watch the videos when you wake up. But you really need to watch the videos the day that they're broadcast, shortly after they're broadcast, if you're in a situation where you're sleeping. If you're not sleeping during lectures, watch the lectures live. Like, it's the easiest thing to do. Okay, so in the hub ain't even gonna load. Well, whatever. So I forgot to introduce myself in the morning section, the 8 a.m. So we just ran through this whole thing once already. 11 a.m. to 1:30 p.m. So I'll not forget to introduce myself. I'm Jesse. I just go by Jesse. I like to keep it casual. I do have a PhD, so if you call me Dr. Hartloff, you're not wrong. I'll still answer you. Professor is fine too. If you want the formality, that's perfectly fine. But I prefer to just keep it casual at Jesse. That's perfectly fine. With the So we're streaming again. I think we got everything sorted out from the 8 a.m. But if there's ever anything, an issue with the audio levels or the quality of the stream, please let me know during the stream. Just let me know right away. I'll have chat open. I'm watching YouTube chat over here. So just let me know right away. There's nothing worse than going through a whole lecture, recording 2.5 hours of content, and then at the end somebody's like, "Oh yeah, the audio was too quiet," or I watch back the stream and realize that the audio was completely garbled and messed up. That's happened before. Like I got a nice mic here. There's no reason for the audio to be crappy. So if anything needs to be adjusted, just let me know, and we'll get some good VODs for everybody to watch. Okay. So the timing is a little bit different than what it says in the hub. It's 11 to 1:30. It does say 11 to 1:40 with a 10-minute break. I usually put this up for a vote. I ask everybody on day one whether they'd rather have the break or no break, go right through and end lecture 10 minutes earlier. And it's always nearly unanimous that everyone says, let's skip the break and just go right through and then have end 10 minutes earlier, which makes sense, especially for remote. Like, you can take your own breaks whenever you want, and you can even back up the video and catch up on what you missed. Like, there's no reason to have a break when it's fully remote. So by default, I'm just going to skip the break and end 10 minutes earlier. And I think that's all the announcements from outside of the course itself that I have to remember. Okay, so let's start going through these. So first, the YouTube link. If you're hearing me right now, you've already found this. I don't have to talk about it. Autolab, this is where you're going to submit your programming assignments. You get unlimited submissions for each of the 8 programming tasks. Go there, submit your code, get the feedback on how much progress you've made on it, and get work on those assignments really as soon as you can. Any code that I show in lecture will be available in this repo. You go to this repo, take a look at any of the code examples. I recommend cloning this repo locally, and I should have time. I had time at the end of the first one to show an example of doing that at the end of lecture today. The memory diagram tool and reference, these will both become very important as we go throughout the semester. I'll even show the tracing tool a little bit today. We'll get to a few examples of that. So these, feel free to use these resources at whenever you like. The tracing tool is what we'll use for the quizzes as well. That's where you'll complete and submit the quizzes. So this will be very important. Piazza, this will go right to the Piazza post with our office hour schedule on it. So you can look up office hours. Office hours will start today. I guess technically they started yesterday. But office hours, I'll have mine after lecture today. And if you want to ask questions on Piazza, if you're sharing any code, make sure you post it private to instructors. Follow regular Piazza protocols. If you're not familiar with Piazza, it's a Q&A forum where you can post questions to the instructors and we can answer your questions. But if you're submitting your code, make sure it's private to instructors. And post to all instructors, not just me. Those are my quick Piazza tips. And then Discord, a little less important in the summer. But Discord, if you want to chat with other students, there's a lot of, I've been using the same Discord server for a long time, so there's a lot of past students in there. If you have any questions about, computer science, CSE116, anything, go into the Discord, start asking. One thing I like to say is when I go through my expectations, I tell you how much time you should be working on this course. If you don't believe me, go into the Discord, go into the 116 channel, and just ask, like, hey, is Jesse full of crap with this whole 116 is going to consume my life for 6 weeks? And I would suspect that a lot of people will confirm that and say, yes, 116, you got to take it seriously. It's a lot of work. It's less important because usually I have Discord chat open during live lectures, and I'm watching that to get some more interaction from students. But we have YouTube chat right now, which hopefully, I always get nervous if it's broken or not. None of y'all have said anything yet. During this lecture, we had like 10 messages in the morning at this time, so I'm hoping everything's working. I'll assume it is, but if not, we do have the VOD from the morning, so it's not going to be the worst thing. But anyway, let's get into it. What this course is, and again, I'll try to keep this more brief than I usually do, so we can get into the content and have some time. Hey, there we go. Hey, I always struggle pronouncing names, but Elzhiri, Ray, Jason, what's up? Jack, what's going on? Okay, thank you for confirming. It works. And there's like a 10-second delay between what I'm recording in chat, so Zoom is only for office hours. That's correct. I don't know why any professors do Zoom lectures. That never made sense to me. And then they always complain about getting Zoom bound. Like, just don't use Zoom for lecture. It's not what it's made for. But anyway, yeah, YouTube for lecture, Zoom for office hours. So in 115, you learned how to write programs. 116, the focus is going to shift a little bit to how programs work. We want to know what's actually going on when we write our programs. And more generally, what happens when our programs get very large? How do we manage those larger projects? And one is going to be unit testing. How do we test our own code to gain confidence that's correct? OOP, which is how do we organize our code into nice packages, especially when we have large lots of pieces of code interacting with each other. We can organize those into objects and classes. And then data structures and algorithms. You have 2 data structures you know right now. You have your sequential data structure, which was your list in Python, and your key value store, which was your dictionary in Python. Assuming you took 115 here, I won't make that assumption too strongly, but if you took 115 here, you have those 2. This semester we'll learn linked lists, trees, and graphs. We'll add 3 data structures to your arsenal to organize our data and work about that data, be able to reason about that data. How are interviews going to work? They're not. Honestly, YouTube is a lot better than Zoom lectures. I don't know why anyone does Zoom lectures. Like, YouTube will host the VOD right after and everything. We have chat, like everything. Well, I guess Zoom has chat, but I don't know. It's just a lot better. You can rewind. If I say something that you're not quite sure of, you can just be a few minutes behind live, and there's just a lot of reasons to use YouTube. All right, so the expectation. So that's what we're going to learn. That's the general overview. Is when our programs get big, how do we manage this code? That's the big theme of 116. Expectations. That you're going to spend 12 hours per lecture since it's a summer class. Whenever I say week, like what am I trying to say here? The weeks in the fall and spring semester basically turn into lectures in the summer semester. So everywhere where you see week, used to see week, turns into lecture. Look, I even forgot one. I should have just done find and replace instead of manually searching, but this is say lecture right here. So a minimum of 12 hours per lecture spent on CSE116. Now, 2.5 of those hours are spent in lecture itself. So if you're watching that lecture, that's 9.5 additional hours outside of that lecture. That's my expectation for the course. On average, or minimum, depending on how you look at this, that's how much time I believe 116 should require of you. Meaning 2 lectures per week, that's 24 hours per week. 5 of that is spent in lecture, so 19 hours per week. That's what I expect you to be able to be spending outside of lecture. 19 hours, mostly working on the programming assignments, but also studying for your quizzes and rewatching lectures, things like that. But 19 hours per week outside of lecture. That's after watching 5 hours of lecture. So 24 hours per week. This is an estimate. It's an average, all those things. So, for example, if you don't do anything outside of lecture this week because there's no deadlines pending, there's nothing pressuring you to start studying for 116, that's 19 hours outside of lecture that you're already behind. And you're going to have to make that up somewhere. Like you're not just going to magically gain all of that 19 hours of practice. That might catch up to you as early as next week. And next week you might be already spending 40 hours, 50 hours in a single week on this course. So don't fall behind. It's my biggest thing. I'm going to keep repeating. Do not fall behind in this course. Falling behind by a single lecture is almost a sure way to fail this course. Do not fall behind. Don't fall into the trap that a lot of students fall into of, I'm not going to watch live, but I'll watch the VOD later, and then 3 days later you still haven't watched the VOD. You're almost guaranteed to fail the course. You can't just fall behind like that and get caught up. I shouldn't say can't. You can, technically possible, not likely. Especially if you're the type of student who is encouraged to procrastinate lectures. You're probably not going to just all of a sudden have a huge interest in 116 and be able to catch up and finish everything. This is an estimate. It does assume that you know all of the 115 topics coming into 116. So if you squeak by 115 with a C or even a B+, and you're coming into to 116 not really knowing everything that was covered inside and out in 115, well, you're already behind. You're already going to be looking at more than 12 hours per lecture because you have to learn the stuff that you were supposed to learn last semester in 115. So you're already behind if you don't know everything in 115. If you didn't crush the course with an A, you're behind already. Not to scare you, but we got 6 weeks here. You got to get on top of it and keep going. You can't be remembering, what was that that accumulator pattern in 115? Wait, what was that again? We got a lot of ground to cover in 116. You're not going to be able to do that unless you're putting in way more than 12 hours per lecture. On the other side of that, if you had AP Computer Science and you've already done some object-oriented programming, especially if you did it in Java, which AP Computer Science does, then maybe you're going to be lower than that 12 hours per lecture because you already know a lot of the stuff that we're going to cover. So it is give and take, but the content that I'm going to cover and to complete all the programming tasks, 12 hours per lecture, 24 hours per week. That's the one I do. If you don't believe me, if you're like every single course I've ever taken has said the same thing, go into the Discord and just pop in and say, is he serious about this? And you'll get a lot of confirmation. How often do we have quizzes? twice. Yeah, one midterm, no quizzes. So I'll and we're about to get through all that stuff. CSE, here's 115 review, some resources. I don't want to really spend time talking about that. But we'll get into the exact logistics of the midterm, final, and quizzes. I still call them quizzes, but they're in a midterm and final, so kind of my nomenclature is all over the place right now. Do we have any quizzes today during lab, today, or activities? Not today, no. I'm currently in Hong Kong, and I wish to stay for lecture as long as I can, but past 12-ish, I like to sleep. Yeah, and that's why I let you watch the VODs. The only 2 lectures that you have to be here live for would be the midterm and the final, which is not today. So if you want to get your sleep and then watch this VOD when you wake up, that's perfectly fine. Lee Isaac, that's perfectly fine. And that's the reason why with how important it is to stay up to date on the course content, I do want to require attendance, force you all to watch the lectures live, take attendance, do lecture questions and all that stuff. I would like to, because that would help you all stay on track. But for this exact reason, some of you are on the other side of the planet where you're sleeping, your natural sleep time is during both lectures. I'm not going to force you to watch in the middle of the night. I can't do that to you. So since it's fully remote and you're all scattered throughout the entire planet, I'm not going to require specific attendance at specific times, except for the midterm and final. I kind of have to. My hands are kind of tied with that one. So 1 to 2 days, you will have to. Okay, so the learning objectives of the course are split into 2 primary categories, with testing kind of sewn throughout both of them. OOP and data structures and algorithms. And both of these are assessed in 2 different methods: reading code and writing code. Reading is the quizzes, the traces. If I say quiz, trace, a memory diagram, all 3 of those I use pretty much interchangeably. I mean the same thing no matter which one of those 3 I say. And then writing, this is your classic program assignments where you're writing code. And for those of you, it was already asked in chat, but those of you familiar with how this course rolls in the spring and fall, you'll notice that interviews are completely missing. So when I very offhandedly just said they won't, how will they work? They won't. They won't. I can't figure out a good way logistically to make interviews work in a summer course. I only have 2 TAs. 2 TAs and myself who just physically can't really do the interviews. I am sad to see them go in the summer, but I just don't see it actually happening in any reasonable way. So unfortunately, they do get cut. You don't get that practice, which I really like you getting that practice for job interviews. After going through the interviews in 116, it makes the job interviews easier, but unfortunately, it just doesn't really work in the summer. So it's just quizzes and writing code and program assignments. And how you're being assessed, the learning objectives are 2 quizzes and 8 programming tasks. And for those of you who are not familiar with 116, which I will assume that a lot of you are, I know a lot of you are, but everything I present, I'll present as though it's brand new to you, because it is for some of you. And so the grading of this course works a bit differently than a regular course, but a percentage-based grading course where you would do your 2 quizzes and your 8 programming tasks. You get some grades 0 to 100 on all of them, average them all together, and some number comes out the other end, and that determines your grade. That's what I would call a typical course. This is not that. For this course, both quizzes and all 8 programming tasks, you must complete all of them to be able to pass the course. Each one of these 10 things is a learning objective of the course that you need to be able to do to be able to move on from 116. And there's lots of reasons. I'll keep it brief here. But the succinct explanation for this is you need to know all this stuff. Like going forward to 220, 250, and in your computer science career, you need to be able to do all of these 8 programming tasks, both of these quizzes. You need to understand all of this material. You need to know it all. With a percentage-based course, it's very easy to miss an entire topic of the course and still pass. And I don't like that when you go on to the next course and you're like, well, I never really understood graphs in 116, but for some reason they still let me go on to 250, and now they're talking about graphs like I'm supposed to know what I'm talking about. Well, it's because you are supposed to know what you're talking about. So you must complete all the learning objectives. or you fail the class. Finish all 8 programming tasks in both quizzes, you pass the class. If not, you fail the class. Pretty cut and dry. If you pass both quizzes, you complete 7 programming tasks, but you just can't get that last one, you fail the class. You have to know how to do all of this stuff. All of this. You can't just skip a topic. Can't skip a concept and move on. You need to know all this stuff for 220, 250. Okay, and let me start with the programming test because it's shorter explanation. The programming test, there's 8 of them. You need to finish them all before their final deadline, and I'll talk about deadlines when we talk about the application objectives next. But you have to complete all of them to pass the class. And the quizzes takes a bit more explanation. So are the quizzes just tracing, or is it more to it? It's just tracing. The quizzes are all tracing quizzes. And we'll see, geez, with how much content we covered today, what was it? 4 or 5 memory diagrams today. Memory diagrams, traces, quizzes. I use interchangeably. So we'll see 4 or 5 examples today of what that means. But those traces that we go through today, your quizzes will look exactly like that. You'll get a chunk of code, and you'll have to trace what happens in memory when that code executes in the stack and heap memory. Okay, so there are 2 quizzes. Those of you who are familiar with last semester where there were 6 quizzes, I condensed that down to 2. Again, timing constraints, logistical constraints. But at the same time, Paul and I Paul's another 116 instructor, have been considering going down to 2 even in fall and spring semesters. We might be going down to 2 quizzes. So that might be a big change in the course. Anyway, definitely 2 quizzes in the summer. And the quizzes are going to be on the midterm and final. The way, and I have this paragraph and all this stuff. I'm not thrilled with the way I wrote all this. It confuses even me when I read it a little bit. So I want to try to give a better explanation verbally right here. We have a midterm and a final exam. The midterm and the final exam will each have 4 traces, memory diagrams, quizzes, whichever word you prefer. So the midterm is going to have 4 quizzes on it. The final exam will have 4 quizzes on it. So they'll be comprised of 4 traces, or what I'm calling quizzes, in terms of learning objective completion. The midterm and final will both have the same exact structure, and there are no separate quizzes outside of the midterm and final exam. All the quizzes are on the midterm and final. The midterm is going to be 4 quizzes, 2 OOP quizzes and 2 data structures quizzes. So for the midterm, you'll get 4 programs to trace. You'll trace those 4 programs, and then, however you do. The quizzes are graded on a pass-fail basis, so you either pass the quiz or fail it for each of the 4. And you can pass a quiz. I get this question a lot, so let's get in before this one. Is you can pass a quiz even if it's not perfect, as long as the mistakes you make are not related to the learning objective. So for example, for the OOP quiz, I'm assessing your ability to understand OOP stuff, object-oriented programming. So if you make a mistake related to a code block, maybe you don't draw your code block, that would be a minor mistake. I can still pass you as long as you got all the OOP stuff correct. Same with data structures. If you got all the data structures content correct, that's what I'm assessing. You can make mistakes not related to the data structure stuff, or like mathematical errors and stuff. I can overlook those, but I can't overlook the OOP and data structures mistakes. Okay, so the midterm is 4 quizzes, 2 OOP, 2 data structures. The final exam is the same exact structure, same exact content, assessing the same exact learning objectives as the midterm, 2 OOP and 2 data structures quizzes. Assessing the same thing. It's going to look like a different version of the midterm is the final exam will. It won't increase in difficulty, not intentionally anyway. It'll be the same thing as the final. So for OOP, across the midterm and final exam, you have 4 OOP quizzes, and across the midterm and final exam, you have 4 data structures quizzes. So there are 4 chances for each OOP and data structures quiz. And if you get any one of the 4 correct, you pass 1 out of the 4 quizzes for OOP or data structures, you've completed that learning objective. So out of these 8 total quizzes that you'll have throughout the semester, you need to complete at least one OOP quiz and at least one data structures quiz. If you pass at least one of each, then you've completed those learning objectives, and then it's onto your programming tests. If you complete all 8 programming tests as well, you will pass this class. So you have 4 opportunities on each, 1 out of 4, and you've completed the learning objective. I hope that explanation makes, so that combined with my paragraph here, hopefully we're all on the same page of what happens here. So let's run through some scenarios. You show up to the midterm, and I'm strongly encouraging you to show up to the midterm prepared. Show up to this midterm prepared, ready to crush these 4 quizzes. You show up to the midterm if you either get all 4 correct, or you get one OOP correct and you fail the other OOP, and you pass one data structures and you fail the other data structures. So you passed it one OOP and one data structures. You've completed both learning objectives for the quizzes on the midterm, and you do not have to show up to the final exam. Did I add a separate bullet point? Did I make that explicit? Even when I make it super explicit, oh yeah, right here. You do not have to take the final exam. Even when I make it this explicit, I will still get this question 20 times at the end of the semester. And I got a typo here. You can make fun of my typo. I got to fix that one. So if you pass at least one of each OP and data structures on the midterm, you do not have to take the final, and your semester can end earlier. You can pass this class earlier. So the midterm, if you show up prepared to the midterm and you crush it there, you don't have a final exam, much less a stressful final exam. If you pass, say, both OOP, but you fail both data structures, you show up to the final exam to do your data structures quizzes, to take your next 2 chances for the data structures quizzes. And now you have a high stress scenario where you have to pass these on the final exam to pass the class, or else everything you've done on the programming task was all a waste. What you did on the OP quiz was a waste. I don't want to see anyone in that position. Ideally, everyone will pass these learning objectives on the midterm and nobody has to take the final. Wouldn't that be a dream world? That'd be absolutely fantastic. If you fail a quiz, you make it up on the final. Yes, that also means, so as long as we're good on this, we can start talking about how you earn your A. If we pass all the quizzes, do we get LOs from all the quizzes passed? Yeah. If on the midterm you pass all 4, you've also completed. So it's at least 1. So if you get completed 1 or 2, 1 or both of the OP quizzes on the midterm, you don't have to take OP on the final. If you pass 1 or both of the data structures on the midterm, you don't have to take the final at all if you got OP and data structures. So hopefully that's clear. It's one of them things that makes so much sense in my head, and then when I go to explain it, I realize that it's more complicated than I think it is. It's not overly complicated, but it's something that we need to be on the same page for. It's very important that you all completely understand that. And I'll probably have to send out emails confirming if you have to take the final exam or not, just to make sure nobody fails because they thought they didn't have to take the final because they got both OP, but none of the data structures, but they got 2 out of the 4, so they got both learned. I don't want anybody thinking like that. Yeah. The final's your safety net is how it ends up working. And this has to be structured different because of this. This is called mastery-based learning, where you have to complete all the learning objectives, but you get multiple chances for each learning objective. So you crush it on the midterm, you don't take the final at all. But if you fumble on the midterm for whatever reason, you didn't show up prepared, you didn't study enough, or you did study and just it wasn't your day, the final exam is your safety net. So it's not just an instant fail the course if you mess up on your first chance. You do get that final exam as a safety net. Okay, so where's your grade coming from? If you complete all the learning objectives, you pass the class. Even if we're going to start talking about application objectives, which is where you earn your grade. If you get 0 application objectives, you completely fumble this entire part of the course, you're still passing. You're not getting a great grade, but you're going to pass the course. And the more application objectives you get, the closer you claw your way up to that A. And especially in the summer, this is true, is every single application objective is related to staying on track, staying up to date with the material. So if you complete all the learning objectives, you pass the class. If you complete them in a timely manner when I'm expecting you to complete them, then you can get your A. So the application objectives are 100% related to when you complete your learning objectives. This is my way of strongly incentivizing you to do your stay up to date on the course and not fall behind. I don't want to see you fall behind. If you do start falling behind, you're probably not going to complete all your learning objectives and you're going to fail. So since you have to do all the learning objectives anyway to pass the class, you have to do all 10 of these to pass the class or you fail. I hope I'm making that clear enough. If you do them in a timely manner, I'll give you the A. There's no extra work associated with the application objectives other than the 10 learning objectives. The 10 learning objectives, that's all you have to do in this entire course. That's how you're assessed, is those 10 things. That's it. So if you do those, you have to do those things anyway. If you do them in a timely manner, you can get your A. Best way to, I get this question a lot, the best way to practice tracing. I would go through the lecture examples. When I do a trace in lecture, after lecture, go to the tracing tool, pull up that code, and without looking at my trace from lecture, try to trace through that code. And then when you're done, look at my example in lecture and make sure it matches. If it matches, then you know you did it well. If it doesn't, then you got something to learn. You got something to study. If you run out of examples there, take any code ever. Take some of your homework code. Take some other code from lecture that I didn't do traces for. Other code in the repo. Go to the tracing tool and trace it. You won't have the solution, but if you take one of those traces to office hours, the TAs or myself, we'd be happy to look over it for you and let you know how you did. Give you some feedback on it. Passing the objectives equals passing the code Autolab assignment. Sorry, this is an obvious question. Yes, so not an obvious question. For the programming tasks, when you submit to Autolab, it's pass-fail, so you either get a 0 or a 1 on the assignment. A 1 means you've completed that programming task. So if you get a 1 for all 8 programming tasks, then you're good on all 8 of those. And then same with the quizzes. We're going to grade you either 0 or 1. Once you get a 1, that means you've completed that quiz. You've passed that quiz. And once you pass 1 OP and 1 data structures quiz, then you're good on that one as well. Okay. So application objectives, I'm going to jump to quizzes first because this one's easier to explain, and then I'll explain all the deadlines and on the tasks. So quizzes, there are 8 application objectives available on the quizzes, and they're all available on the midterm. Again, this is my way of encouraging you to stay up to date. Every one, there are 4 traces on the midterm. Every one of those traces that you pass on the midterm, I'm going to give you 2 application objectives. So if you pass all 4 of them, that's 8 AOs right there on the midterm exam for doing something that you have to do anyway, passing some of these quizzes. So 8 right there, and that's a pretty big boost in your grade. That takes you all the way from a D to a C, or you can look at any jump that you want to compare to, but 8 is quite a big jump. It's a third of the AOs entirely. So I'm strongly encouraging you, show up to this midterm prepared. 1, you don't have to worry about the final exam. If you do well on the midterm, you don't have that stressful final exam, as I already mentioned a few times. But also, you can get a big boost in your letter grade if you crush that midterm exam. Show up to that prepared. The reason I do this so much is I've had, in the past with less incentives, students will say, well, I'm just going to blow off the midterm because I can just take it on the final. I'll study for the final. I don't have time to study for the midterm, so I'm not going to bother. It's basically a free roll. If I do good, I don't have to take the final, but if I do bad, I'll just take the final or whatever. Which is a horrible attitude, and those students almost always fail. So I don't want anyone doing that. I don't want you setting yourself up for failure. Don't rely on that final exam. Take the midterm extremely seriously. I will give you a good grade boost if you do so, and you don't have to take a stressful exam. Just take the midterm seriously. If you get 8 objectives passed on the midterm, can you potentially get another 8 on the final? No. So on the final exam, there's no chances for application objectives. The final exam is a safety net to give you one last chance to pass the course. If you're relying on that safety net, I am not giving you any application objectives. You can squeak by with a D. I don't care. I don't want anybody relying on that final exam. It's there in case you need it. You're not going to get a reward for needing it. Okay. So no application objectives available on the final exam, only the midterm for quizzes. The other 16 application objectives are coming from your programming tasks, and this is directly how fast you complete these programming tasks. I want you to stay up to date on these things, up to date on the content, and here's my incentive to encourage you to do that. There are 3 deadlines for each programming task. One is the expected deadline, which is 8 a.m. 2 days after the material for the task was covered in lecture. So this is a very fast timeline. It can, because summer just moves very, very fast. And this is the deadline that makes sense. So this is less. This is less than 48 hours from the end of lecture, or for the 11 a.m. lecture, it's less than 48 hours from the beginning of lecture even. So this is extremely fast. This is a very tight clock. And the reason for this 2 days is when it's a Tuesday lecture, 2 days later, we have a Thursday lecture. If you're still working on Tuesday's lecture's programming task, by the time Thursday's lecture comes, you're falling behind. Like, you're behind by a whole lecture now. I'm lecturing about material that's beyond a programming task that you haven't even completed yet. At that point, you're falling behind and you're at risk of failing already. So this is my expectation. I expect everybody to be able to do this. That's why it's called the expected deadline, is finish everything in 2 days. And I encourage you to treat the course as a 4-day work week. You're working Tuesday lecture, Tuesday after lecture, and then Wednesday you're working on the programming test for Tuesday. Go to Thursday's lecture, and then the rest of Thursday, and then Friday you're working on Thursday's programming task. So Tuesday to Friday, that's when I would expect you to work on 116, and then take your 3-day weekend, take your Saturday, Sunday, and Monday, and then get ready to do it again next Tuesday through Thursday. So treat it as a 4-day work week. And again, 24 hours per week. Those are, I almost did my math way wrong. Those are 6-hour days, so it's less than a full-time job even. Usually jobs would have 4 10-hour days if they do that. So you still have extra room in your schedule. It's not too demanding in that sense. It's not a full-time job. The deadlines on Autolab, the due date is the expected deadline, and the last day to submit is the final deadline. But the schedule, if you scroll down on the schedule, it has all the deadlines for everything, which would be the way to make sure you're following the deadlines. The only opportunity to get objective points is the midterm. The final is only pass. If you get 2 of 8 on the midterm, there's no opportunity to get the missing 6 points, full stop. Yes. Yeah. The only caveat, I think this is what you meant anyway, but aside from the 16 from the deadlines that we're talking about now, for these 8 on the quizzes, only available on the midterm. Get them on the midterm or don't get them at all. So if on the midterm, and I'm always careful about the range that I make for an A. If you fail 2 of the quizzes on the midterm, you can still get an A as long as you're keeping up to date on all your deadlines. So it's not, the absolute end of the world if you don't get them, as long as you are keeping up with everything else. And you could still get a B plus even if you completely bomb the midterm. Which I don't think is true in most classes if they use percentage based. So expect the deadline 2 days after. And I'm telling the TAs to prioritize office hours in that range, that Tuesday through Friday. We have a few on Monday already, but Tuesday through Friday will be the important time for office hours to monitor Piazza. That's the way I want to, where I want most of the support, because that's when I'm expecting you to be doing the work. Each time you meet an expected deadline, that's 2 AOs. And my office hours are Tuesdays and Thursdays. I'll have office hours after lecture today. I gave myself a half-hour gap so I can eat lunch and stuff, and then I'll go into the Zoom meeting for office hours today, starting today. Late deadline is 8 a.m. 5 days after the material's covered. I chose 5 days because that's when, if it's a Thursday lecture, that's when the Tuesday lecture is going to start. It's 5 days later. So even on a Thursday, if you get it done in 5 days, at least you're not bleeding into the next lecture. But you did have to take up your 3-day weekend to work on 116, which probably isn't what you want to do. Maybe you do, I don't know. But and I already said this, right? The expected deadline, if it's a Tuesday lecture, the expected deadline is before the next lecture. The late deadline gets you to the next lecture on a Thursday, but really get it done by the expected deadline, which will be on Friday. Saturday morning, but effectively Friday night. And then the final deadline is going to be what I think is pretty lenient. I don't know if I should have tightened this one up, but 11:59 p.m., so midnight, 11 days after the material for the task was covered, which, if you're relying on any of these final deadlines, you are at strong risk of failing the course. 11 days is a lot in this summer. 11 days, there are several lectures that are passing you by as you're still working on this assignment. If you're 2 to 3 lectures behind, I don't see you catching up by the end of the semester. I just don't see it happening. So 11 days after that, I don't want to give you any false hope. If you're 11 days behind on your task, there's no sugarcoating it. You're going to fail. Like, it would take a miracle student. You have to completely turn into a different student entirely, with different habits and everything, to be able to come back from that. Students who dig themselves a hole like that can't get out of that hole. So I'm not going to give you any false hope. After 11 days, I'm just going to cut you off and say, sorry, F in the course. Like, you're never going to catch up. So part of that's no false hope. The other side of it is a strong push, a strong encouragement. Like, you can't fall 11 days behind in this summer course, this 6-week course, which is really only 5 weeks. What would be the 12th lecture is the 4th of July, so we don't have a 12th lecture, and the 11th lecture is the final exam. So it's really only a 5-week course. If you're falling 11 days behind on a 5-week course, like, the whole semester is only 35 days. 11 days from now, we're going to be through a lot of the content. It's 40% of the content. Is that true? 7 and 4. Yeah, we're going to be through 40% of the content of the course 11 days from now. Which means by the task 1 expected deadline, we'll be through 60% of the content of the course before we hit our first final deadline. If you haven't completed task 1 by then, you will fail. Like, I don't see any way that anybody could come through with that. If you can't complete task 1 in that time, you're never getting through. Tasks like 6, 7, and 8 are way tougher than task 1. You never do it. Anyway, expected deadline, each expected deadline you meet 2 AOs. Each late deadline you meet 1 AO, and each final deadline, if you're relying on the final deadline, you ain't getting any AOs. I'm not rewarding that behavior. Stay up to date on the material. Stay up to date on the programming tasks. And I'll reward you and let you move closer to that A. If you're relying on final deadlines, no. I see students who will ignore the first 2 deadlines and just aim for the final deadlines because that's the one that really matters. Even if you do make them, I'm going to give you a D, assuming you did poorly on the midterm as well. But also, you're more likely just going to fail the class because you're going to miss one of those deadlines. It's too high stakes. Don't do it. I give you that offer because, sometimes there's just one task that a good student will just struggle on for whatever reason. I want to offer you this safety net, but do not rely on that, or you're almost guaranteed to fail. So keep up to date on the material. keep studying and working on things as you go through the course, and most of you will be fine doing that. Go to office hours when you have trouble. Do not aim for the final deadlines, or you're not going to be fine. It is have I said this enough times? I think I'm harping on it too much, but the slacking off in this course is the easiest way to fail. It's the number one reason. It's why I see so many students fail. Way too many students failed last summer. So I tightened up my incentives to incentivize you to stay up to date, because I don't want to see that many students fail. I don't like seeing it. Okay, so that's how you're graded. Let's move on. No textbook. If you need counseling and stuff, here are the links, or let me know. I'll always talk if you need advice, anything. And then academic integrity, I do have to talk a little bit more about on this one, unfortunately. Any violation is an F in the course, no matter what it is, whether you're the one helping someone or you're the one getting the help, I don't care. No matter what of these things you've done, I don't care. Every single violation is an F in the course. There are some things that you're allowed to do. If you want to talk abstract solutions with other students, that's fine. If you want to talk about your approach to the homework, like oh yeah, I was going to use a linked list, and that linked list is going to store my songs, and then maybe I'll go through those songs and take all the ratings and average those together. That's kind of my idea of how I'm going to approach this. That's fine. There can be a fine line where you start crossing it, and that line is when you start talking about the code itself. So if instead you say, I'm going to create a linked list, I'm going to create a variable and store it in a linked list, then I'm going to write a loop, and I'm going to store each node in a variable, and then advance that variable to the next node, and as long as that node is not null, then... So at that point, you're just explaining the code. You're just telling somebody the code. They're going to type up that code and submit that. And when they submit that, your code is going to look identical, or nearly identical, because it's the same code, because you just told them your code. I keep hearing the excuse in the AI meetings when I'm failing students for cheating. They'll say, oh, we were just talking about abstract solutions, because they know that that's allowed. But if you're talking about it in so much detail that your code ends up looking very, very similar, you didn't share abstract solutions, you shared code. And they always say, well, I didn't literally cut and paste code. Like, yeah, I don't care. You verbalized all of your code out loud, and they typed it down or whatever. In most cases, I think they actually did just share code, and they're bullshitting me. But even if they do verbalize it and the other student types that verbalization up, they shared code. You shared code at that point. I'll keep this brief. I gotta get to the content. I spent too long explaining grades. But I want to highlight a couple of these. This is the most common form of violation. This probably won't be as important in the summer class, but I still want to point it out just in case. Is students collaborating with each other to complete an assignment. I usually see this, I'll see students do this right in front of me. They'll do it sometimes during lecture, often during office hours, where two students will sit next to each other. They'll both have the assignment open on their laptops, where they can see each other's code, and they're often looking at each other's screen. I'll see students in lecture looking at another student's screen and pointing at things and stuff like that, right in front of me. And sometimes I have to go out there and fail them and say, dude, you can't do this. You're cheating right in front of me during lecture. What the hell is wrong with you? You can't do that. You can't work on an assignment together. If you were sitting, say, across from each other where you can't see each other's code and you're just sharing abstract solutions, that's fine. It's nice to have some company when you're coding. But once you're sharing the code, that's the biggest reason why students, sometimes they don't know that they're crossing the line. But when they submit their code, it looks almost identical. That's how I catch them, is I see all the similarity between their submissions, and at that point, I don't care how they got that similar, to be honest. If the code's that similar, it's 2 Fs that I'm handing out. Sucks to see. That's why I'm warning you now, because I don't want to see anybody fall for that. Probably less important in the summer, but if you are tempted to do Zoom calls together or Discord calls or whatever, just be careful about that line. Using AI to write your code, ChatGPT is becoming more prevalent. You have to write your own code, or else or else why are you even here? I never understood this one. Like, you're here to learn how to write code. If you have your AI write code for you, like, at some point, ChatGPT is not going to be able to do your assignments, and you're not going to have any of the background you need, and you will fail. If I don't catch you this semester, there's going to be a course where you just have no idea what to do because ChatGPT suddenly can't do your assignments for you. I don't understand the mindset behind this, but some students do it, and yeah, a lot of these are self-explanatory. The last one, I just added this, so I'm going to start harping on it more. Hopefully this doesn't come up either this semester, but just in case, I'm going to start adding this to all my AI policies, is asking me or TAs to falsify your grade. Just don't do this. Hopefully most of you are just, or all of you are just like, why would anybody even try to do that? But you'd be surprised. A lot of students do this. They'll send me an email after grades are posted, and they'll say, hey, I know I earned a B minus, but it'd be really cool if you just gave me a B plus. Like, can you just do that? Like, no. I'm going to start changing those grades to Fs. It's going to be part of the AI policy. I'm changing their grade to an F if they do that. This is very different than challenging your grade. If you think there was a grading mistake, if your argument is, I truly believe I earned a B plus, that's very different. So always, if you think that me or the TAs made a mistake, always, challenge that, let us know, reach out, complain, argue, whatever you got to do. And then I'll at the very least look into it and make sure that we didn't make a mistake, or if we did make a mistake, I'll give you the credit. That's very different than asking me to falsify something. Asking me to falsify something means you did not earn that grade rightfully, but you just want me to give you the grade anyway. That's enough. That's AI. I'm so sick of those requests that I'm going to start failing those students until word spreads that you shouldn't ask me to falsify your academic record, because holy crap, why? Ridiculous. Okay, 11:51. So the lectures are 50 minutes during the semesters. So we have 3 50-minute lectures back to back for each summer lecture, and the schedule is broken down into, this would be a Monday lecture, a Wednesday lecture, and a Friday lecture, all back to back. So 11:52, we're 2 minutes behind. We'll get this. We got this. Okay. I should have just kept these open from... Actually, let me do this a little smarter. Right. Okay. Content, finally. We got through syllabus day. Okay. So, intro to Java. So, there was some tangent I went on in the previous lecture. I don't remember what it was, so hopefully it wasn't too important. All right, so our first Java program. Let's talk about Java. So this lecture and Thursday's lecture, we're going over Java basics, and then the next 8 lectures will be 1 lecture per programming task. So that's where we'll start learning our homework content. For these first 2 lectures, it's Java syntax. I'm going to assume that you know the basics of programming, you understand what programming is and all that good stuff. Variables, loops, functions, which I'm now going to call methods. That you know all that stuff, and I just got to show you the Java specific stuff. So for 2 lectures, we're going to talk about Java syntax. These lectures are going to go extremely fast. It's going to be a lot of little things at rapid fire. And this is where I really strongly recommend, as always, doing your 12 hours per lecture. It's easy to neglect that this week and not do your 19 hours outside of lecture this week. But I strongly encourage you, do some Java. Ideally, I think this was the tangent I went on before. Ideally, go to task 1 and start working on task 1 right after today's lecture. You can't do the testing part of it, so you can't really do all of it. Yeah, this is the tangent I went. So you can't really do all of it, but all of the lecture content that I'm going over this summer is the same content as I just went through in the spring semester. So if you go on this channel, go to the videos and go through last semester's content. It's all the same lectures, same content. I only had 2 weeks between semesters. It's not like I could go through and update everything. So it's the same stuff, same structure. And you can go specifically to the unit testing lectures. You can go through the whole semester today if you wanted to. Well, there's too many not enough hours in the day unless you watch 2 times speed. Anyway, but you can go through all the lectures if you want. But specifically the unit testing lectures, if you watch those ones, you can get started on task 1 right away instead of waiting until we cover unit testing to be able to do task 1. So you could do that, or at the very least, study your Java syntax. Make sure you know how to write basic Java programs. Writing 115 level programs in Java, that's what you got to learn this week. If you don't do that, if you don't put in your 19 hours outside of lecture this week, guess what you're doing next week, or whenever you start task 1, is you're catching up on all that, and you're already going to be behind, and you're going to spend 50 hours next week doing tasks 1 and 2, and it's not going to be fun. Because if you're the type of person who thinks that's fun, you're probably coding this week. Like, you wouldn't wait until next week to get started. Okay. So here's Hello World in Java. Let's break this thing down into its pieces. Here's the package declaration. So package declaration is specifying effectively what directory this code is going to live in. If you look at the examples repo, linked from at the top of the course website, it'll have all the code from lecture examples, as I said before. And when you see a lecture example, if you're wondering where the code lives, all the code lives in the source directory, src, and then the package is going to specify which subdirectory it lives in. So package week 1, then that means this code lives in a directory source/week1. That's where this code is going to be. The package declaration has to match this directory structure exactly. So if the package is week 1 and I have this code in directory week 2, this code's not going to compile, nothing's going to run, everything's broken. Java's going to yell at you for that. Next is the class name. All code in Java must live within a class. And there's a little asterisk on that. Later on in the semester, we'll learn about interfaces, which are kind of a different flavor of class. But all code lives in a class. So we need to create a class and then a code block for the class. That's where all of our code is going to live, aside from package declaration, and eventually we'll see import statements on Thursday. Are the only pieces of code that live outside of a class. The class name is going to determine, the class name has to match the name of the file. So I have some class I'm declaring in this file, and the file name has to match that class name. So this class Hello World has to live in a file named helloworld.java. And since it's package week 1, it has to be in directory week 1. So the package declaration and the class name tell you exactly where to find this code in the project. Java will enforce both of those, the class name and the package matching the directory. Those in the class name matching the file name, those have to match or else the code doesn't work. So you can guarantee that this code can be found in this location. Next is our main method. Oh boy, the main method. This is one of the things that makes Java pretty confusing right from day 1. So let's break this down. We're not going to learn in depth what everything here means, but by the end of the semester, we will. We will dive into everything eventually, but not today. Not today. It's just too much for day 1. So the main method, and I am going to say method, not function. If whenever I say the word method, you hear function, that's perfectly fine. I'm okay with that. There is a slight subtle difference. Again, something we'll talk about later in the semester. We'll learn in detail what the difference is. For now, the difference between a function and a method, if you put a function inside a class, it becomes a method. It's magically a method now. Since all code in Java has to be in a class, we don't have functions, we only have methods. So I'll say method all semester, but everything you know about functions will apply to what we talk about with methods in Java in 116. So the main method is the method where your program starts. If you have a method that looks just like this, with this same signature, then that's going to tell Java, this is where my program starts. If I run this class, if I run this file, what I'm actually doing is running the main method of that file. That's where every Java program starts. To have a main method, we have to have quite a few ingredients: public, static, void, main, string array, a bunch of different things here. So let's break them down very briefly. Again, we'll get into depth on each one as they come up naturally throughout the semester, but that place is not the main method. Static means that we can call this method without doing any extra work, and we'll see later that extra work is creating objects of this class type. If we have a non-static method, we need to call it through an object of type hello world in this case. A static means we can call it through the class itself, so we don't have to do any extra work to call this method. Void means the method doesn't return anything. Main is the name of the method, which must be exactly main. If I have a capital M here, I no longer have a main method that Java recognizes. So it has to be all lowercase letters, main. String array, this method takes one parameter of type string array, which is going to be the command line arguments. We're not going to use command line arguments in 116, so we VOD check. Am I supposed to do anything with that? I never heard of VOD check. Oh, in case I'm just replaying. So I did think of that. I could just replay the 8 a.m. lecture and not have to lecture twice a day. But no, it's definitely not a VOD. We're live. We're lively, Isaac. So string array is the type of this parameter. We're not going to do anything with the command line arguments in 116. Yeah, you can call me out anytime you want. It's going to be live. I'm going to, as much as I don't, it's not my favorite, I'm going to lecture the same stuff twice a day. 5 hours total a day I'll be lecturing each lecture day. So we're not going to use this, but it does have to be there. If this string array is not here, Java will not recognize this as a main method, and your program is not going to run. The one thing that can change with this main method is args. Args is the name of the variable, so you can name it whatever you want, but by convention we usually keep args short for arguments. There's no reason to go against convention, but that is the one thing that could possibly change. And then public, the one that I skipped here. Public means this code can be used from anywhere. So if we're running our program from IntelliJ, from outside of the class, we need to be able to access it. So the class and the main method have to be public, so we can access this code from outside of this class. So if you think that's a lot, that is exactly why we don't use Java in 115 anymore. That's a lot for day one hello world versus in Python print hello Python. There's your first Python program. This is just a lot. The good news is most of it's overhead. Everything outside of this actual one line of code that we're going to look at is just boilerplate. And the IDE, IntelliJ, that we're going to use does take care of a lot of this for us. If we create a new class, call it hello world, and then type main and hit enter, it's going to give us a main method with the exact signature that we need that's going to work for us. So these days we have tools available. We have these IDEs available for us. There's no reason to memorize this. You probably will eventually. Just writing enough Java code, you'll end up memorizing this public, static, void, main. You're going to end up memorizing it. But we don't have to, which is a really nice feeling. And finally, we can write some code that runs. Everything else is boilerplate. This is the only line of code that really does anything in this program. And it prints hello Java to the screen. Hello world is, it's where we got to start, where we like to start with every programming language. And for this, even this has to be a little more confusing than it has to be. System, capital S, .out.println, lowercase p, lowercase l, and then whatever string you want to print to the screen. This is the equivalent of print in Python. System.out.println. And luckily, we don't have to memorize this either. If you just do s out in IntelliJ and hit enter, it's going to complete this whole thing for you. So you create new class, name your class, type main, enter, s out, enter, and then hello Java. That'd be the quick way to get this program, to write this program. And then every Java statement ends in a semicolon for what it's worth. Don't forget your semicolons, but again, IntelliJ, all modern tools, modern development tools, very good about yelling at you and saying, hey, you forgot a semicolon here, maybe put your semicolon there. Okay. And I might start doing things a little bit different between the 8 a.m. and the 11 a.m. Might not, but let's give it one try here. Is to do a little more live coding in the 11 p.m. I already went through the slides, so I have to do this super quick before we lose track of time. But here's IntelliJ. If I deleted my Hello World, if I go to week 1, new class, Hello World. Sure, add it to Git. That's going to create, since I created this in the week 1 package, it gives me my package declaration. I named it Hello World. It gives me my public class Hello World and my code block. It does a lot of that for me. And then main, it's going to come up with my autocomplete. S out. Hello Java. And then when I write my code to run it, I have a few choices. I can either right click over on the file name and run it, which is my preferred way to run the code, or we can click one of these go buttons on the side next to our classes. Then we get all this crap. And then our actual output of our program, Hello Java, it prints Hello Java to the screen. Ooh, I gotta find smoother transitions if I'm gonna be bouncing between the two. Okay. So there's our very first Java example. And do I dare try to do this the live coding way? So Paul, one of the other 116 instructors I co-teach with every spring, he does nothing but live coding, and then I usually do mostly slides. I slip in a little bit of live coding every once in a while. So to get the best of both worlds, if I did slides at 8 a.m. and then live coding the Paul way at 11 a.m., that's kind of what I'm thinking. But you know what? Let's give it a try. If this if y'all hate it, let me know and we'll go back. But let's delete this and live code it. What did I call it? Variables, functions. And my biggest concern is that my timing will be all off. So as long as I can stay on track time-wise, I would like to do it that way. So for this, I want a main method. But we're also going to create, oh, this is different. This is weird. We'll call this an experiment. If you don't like this style, let me know. But ideally, if I do both and you don't like this style, you can watch the 8 a.m. We'll see how this works. But I said this in the email, but I don't care which lecture you watch, or if you watch the VOD. No, I said that earlier today. Never mind. And in the email. So I want to create a method. To create a method in Java. Yeah, good point. So I don't want to create a method yet. I want to create a variable. So I'm going to create a variable. I'm not creative, so I'm just going to call it X and 4.6. So the biggest thing in Java, the new thing in Java that we have to talk about is strong typing. Java is a strongly typed language. So when I declare a variable, in Python I would just do this, x equals 4.6. In Java I'm getting an error with this. Cannot resolve symbol x, because I'm trying to use a variable that hasn't been declared yet. I have to declare every variable that I'm going to use, which Python doesn't make you do. Java does, and for a very specific reason, it needs to know the type of every single variable. So instead of just creating a variable, I have to create a variable with a type. Double x equals 4.6. This is, I'm creating a variable named x of type double. And what this means is x can only ever store a double, which is a number with a decimal portion. X can never store hello. X can never store any type that's not a double. If I try to assign a string, it's going to say X is a double and you try to give it a string. What the hell are you doing? That's not how coding works. So I can never reassign X to a value that's not a double. There are only a few exceptions to this. Like 4 without a decimal portion is an integer value, which is a number without a decimal portion. Java is good about auto-converting ints to doubles for us. But other than a few minor exceptions like that, we do need to match the type. So the type has to match. Every variable needs a type. We can see args has a type also. String array has a type. So let's create our first method. I'm going to create a public static method. So public static, for now, every method that we create is going to be public, both public and static. So we can call the code from anywhere, and we don't have to create an object to call the method because we don't even know what objects are yet, so we don't have to do that. And I'm going to create a method multiply by 2 to try to keep it consistent with the slides. And when I create a method, one of the big new things in Java, actually let me start with the parameter. So I'm going to have a parameter, I'm going to name it input, and the parameter, every parameter is a variable. If every variable needs a type, my parameters also need types. So I need to put a type here, and spoilers, every type is going to be double in this example, but as the semester rolls, we'll see a lot of mixing of types. So this method takes a double as a parameter, and I'm still getting a whole bunch of errors here. It's going to yell at me because I have no return type. Every variable needs to have a type, and also every method needs a return type. So I have to tell Java what the type of the value is that this method will return. And once I have that type, so I'm going to say this method returns a double, so this method takes a double and returns a double. Once I specify that return type, I am signing a contract with Java and saying this method will return a double. Whatever I return, it will be a double, and Java's yelling at me right now because it's saying you told me you were returning a double. You didn't return anything. You don't even have a return statement. So I'm going to have to return a double. Our parameter is when you're defining a method. Parameter is this right here. Well, let's set up some more code here. X equals multiplied by 2 of x. When I call the method, that's an argument, which I think is what you're saying here. When you call the method, an argument is when you call the method. Yep. Yeah, you got it right. So this is parameter when I'm declaring a method, when I'm defining a method, and argument when I'm calling the method. So parameters get assigned the values of the arguments. Okay, so I have a problem here. I said I'd return a double, but I didn't return anything. So Java's not going to let me get away with this. I can try to run this code. I'm going to get nothing but errors. And we can minimize the project bar too. Missing return statement, not going to work for me. Okay, so we know we need a return statement. We do have to explicitly return whenever we want to return something. And we could do input times 2. Would work just fine for us. But I want to declare another variable just so we have more stuff to talk about here. Is double, I'll call it result, equals input times 2, and then return result. And it's going to yell at me a little bit. It's going to say, that's redundant. Why are you doing this? You could just return input times 2. But I'm doing that just to show whenever we declare a variable, we need to specify the type. When we reuse the variable, I'm reassigning a variable here. I'm returning a variable here. Whenever we use the variable after it's declared, then we do not specify the type again. So I'm not saying double x equals 1.2, for example. In fact, if I did, it'd be an error. Whenever you specify the type of a variable, you're declaring a brand new variable and adding that to the stack. So if I'm trying to declare a new variable named x and add it to the stack, I'm going to get yelled at because x already exists on the stack. Now I have duplicate names of the same two variables with the same name, and it's not going to work for me. It's just not going to work out. So I can't redeclare a variable of the same name. And whenever I want to reuse a variable, I do not specify its type again. Okay, and if we run this code, oh, it doesn't, I'm not printing anything to the screen. So let's do sout x. So now we have 1.2, goes through this method, gets multiplied by 2, and then prints out 2.4. Okay. And then one last thing about methods, for now anyway, is not all methods have to return something. In fact, our main method is one such method that doesn't return anything. If a method doesn't return anything, then we can give it a return type of void. Every single method needs a return type to specify what type it returns. If the return type is void, this is our way of saying it doesn't return anything. It just doesn't have a return type. And I don't have a return statement. I don't do anything with a return value. I don't assign the return value to a variable or anything. I'm not doing anything with return values. So I can say void to say I'm not returning anything here. And when we call a method that returns void, we call it for its side effects. So this has the side effect, this method has the side effect of printing to the screen, why does this method exist? Why would you ever write a method like this? You wouldn't. So it just prints to the screen like, why is this a method? Why is this here? And not return anything. I have no return statement. I can, for what it's worth, I can still have a return statement to say I want this method to end right now, but you don't need a return statement. And then let's keep going. Let's just go to the next example. I gotta get used to just doing everything from memory, which should be fine. I just went through it in the previous lecture. Let's start talking about different types in Java. So this example uses just double, which isn't super interesting. There's doubles everywhere, but for the very first example, I wanted to keep it to one type. But let's talk about a few other types. So double is when we have a floating point value. A floating point value meaning we have some decimal portion allowed. And this can be 0. Or I can just have nothing and have it assume, convert that to a double. But anyway, double is when we want a decimal portion. And doubles, for what it's worth, cannot be represented exactly in the computer. But that's a topic for another day, which will be next Tuesday. A week from today, we'll be talking about double precision, floating point precision, stuff like that. Not today. So let's see another type. There's 4 major types that we're going to use throughout the semester. 4 like basic types, and then we'll start talking about objects and have more complex types. But int is a number that cannot have a floating point value. So int is going to be a whole number. Has to be a whole number. It can be negative, that's allowed, but it has to be a whole number. If I try to do 5.9 or even 5.0, this isn't allowed because it has a decimal portion. Ints can't have a decimal portion. String, I'll stick with hello because I can't think of examples on the fly. String is going to be just what it was in Python or any other language you're coming from. It's a sequence of characters. And you'll notice that string does start with a capital S. This does have a lot of meaning that we're mostly going to ignore. in 116. So any type that starts with a lowercase letter is what we call a primitive type. It means variables of that type store values directly. This variable stores the value 4.0. This variable stores the value -5. But anything that starts with a capital letter is an object type, which means that it's stored by reference. So Word stores a reference to an object on the heap that has the value hello. So a subtle difference, but for strings, we're actually going to pretend that they are primitive types. This is something that bugs me a little bit, but I made my peace with that. It might bug some of you as well. And it certainly will bug your 220 instructor, who will have to fix this misunderstanding and say, no, this is how strings actually work. And it'll be char stars at that point because it'll be in C. But we're going to pretend, for the purpose of our memory diagrams, we're going to pretend that strings are primitives and that they are stored by value. So on our memory diagram, we'll have the variable word, and then right next to it, we'll have the string hello as its value instead of a reference to an object on the heap. We do that to simplify things, doing objects on the heap and immutability. Strings are immutable in Java. Doing all that in our memory diagrams is tedious, it's painful, it sucks, and detracts from what we're actually talking about. Yes, strings are mutable. And that's the 10-second delay. We're saying it at about the same time. Are strings mutable? No, strings are not mutable. They are immutable in Java. Strings are immutable in Java, which will come up in one point in next Tuesday's lecture, but it's not something we really need to understand in 116. The one place it's going to come up is that we can't use equal equal to compare two strings. We have to use the dot equals method. We'll talk about that next Tuesday, but that's the one thing you have to remember for that. But other than that, we're going to pretend they are primitives because that's how they behave. Because they're immutable, they behave as though they were values and not references. So all that to say, a lot of that shouldn't really make sense unless you have some background in that already. So it's a lot of explanation for that, which is why we treat them as primitives. So I don't really have to give that explanation. I give this as a quick disclaimer for those of you who know. If you know about how strings work in Java, I just want you to know, yes, they do work that way. We're going to pretend that they don't. Okay, so that's strings, and then the last one is Boolean. Bool equals true. I don't have much to say about Booleans. They're true or false. For what it's worth, lowercase t, lowercase f, whereas in Python they were capital T, capital F. So not much to talk about with that one. And then I'm going for it. I'm going to do the whole Paul thing. I'm going to copy this code. Do I want to add I'm going to add a parameter here. String. I'm going to name it word even. Just so I can make a different point. We're going to do the whole thing. So I'm going to go up to the top of the website, go to the memory diagram tool, or it's tracing.csc.buffalo.edu if you want to go to it directly. And then go to trace practice. And then I really had to finagle this. I got to make a feature request because this is janky. But I was able to hack this. No, I did it this way. I don't know if there's got to be an easier way. There's no way they tested that and said this is good. I might be just doing something wrong there. But until I figure out what I'm doing wrong, we'll do it that way. Okay, so here's my code and here's the memory diagram tool. I do also have slides which show the traces in a different way, which isn't exactly how they're going to be presented here. So I would like to start using this during lecture. I was able to sneak in a few examples in the other lecture, but let me try to just do all of them in the tracing tool, so they're all exactly how you're going to do it for your quizzes. This is the tool you'll use. You'll submit through the tool. We'll grade through the tool. All your traces are going to be through the tool. We used to do these by hand, and it was a pain, but now that we have the tool, I got to start adjusting everything over. All right, so we're going to do our first memory diagram trace. Our programs always start with the main method, so we start at the beginning of the main method, and we're going to trace through this code line by line and keep track of everything that it does. So the first thing we do, we have a method call. So we have a new stack frame, and a lot of this, by the way, should be familiar from 115 if you took it there. Some of you have not taken 115 with memory diagrams, or didn't take 115 at all. You took your CS1 somewhere else. So I will take this from the top and try to explain absolutely everything. We start with the main method. That's where our programs start, and every program starts with a main method stack frame. Every single method call is correlated to a stack frame, and that includes our main method. So the main method creates a stack frame. We're going to label this stack frame main. And technically args is on the stack, but we don't trace that because in 116 we never use it, so we just don't bother tracing args. But we're going to have a main stack frame, and then each time we have a variable declared, the stack is split into name and value. We're going to add the name of each variable to the stack. This is a variable named x with the value 4.0, and put its value in the value column. So we have a main stack frame, and we're tracing one line at a time and going through this code exactly the way a computer would. Exactly how the computer would go through this code. That's what we want to do. So when the computer reads this line, they're going to add to the stack, which is basically a lookup table for variables to values. It's going to add to the stack inside the main stack frame a variable named x with the value 4. And then it's going to execute the next line. Number equals -5. So add a new variable, number, -5. And notice that when we add variables to the stack, we are not adding its type anywhere. We just don't annotate the type in our stack frames. If you want to know the type, you'd have to refer back to the code. We just don't put it in our stack frames, in our variables. And then word, new variable, word with the value hello. I'm not too picky about this, but it's good to get in the habit of knowing when to put your quotes and when not to. Since Word stores a string, you should put quotes around the word hello. Some professors will be picky about that. So it's good to get in the habit, even though I'm not going to, with pass-fail grading, I'm not going to turn your pass into a fail because you forgot some quotes. Like, if it was percentage-based grading, I would take like a -5 off of it and give you a 95. But the way the course is structured with mastery-based learning, I'm not doing that. Bool, true. And then we have our first variable reassignment, x equals 1.2. So we have x on the stack, and we know that has to be on the stack because I don't have a type declaration. So this isn't a variable declaration. This is a variable reassignment. X equals 1.2. We do not just change the value in the stack frame like that. What we want to do is click this cross out button, cross out the value, and then put 1.2 in its place. The goal of our stack traces is that we are tracing through the execution of the program and keeping track of everything that happens in memory while the program executes. So we never want to lose any information. We're always keeping track of all of the history. So even though in the actual computer, when this program runs, the value 4.0 will be erased and 1.2 will be put in its physical place in memory, that's what will actually happen. We want to preserve the history in our traces, so we cross it out and write the new value in. So then when we're grading these things, or when you're looking back at your trace to figure out what happened in the program, we know that 4.0 was the value of x, and then it was reassigned with the value 1.2. Okay, and next, multiply by 2. We have a stack frame, a method call. Every method call creates a stack frame. So multiply by 2 of x is going to create a stack frame for this method call of multiply by 2. So we're going to create a new stack frame on the stack, and we're going to label it the name of the method, multiply by 2. A string array, yeah, that's specific to the main method. So this annotation means that it's an array of strings, which is something we're going to tactfully avoid in 116, dealing with plain arrays. We're going to use array lists instead. But this means it's an array of strings. So if I wanted to get the value at index 0, I would do args of 0 using that Python-like syntax. So multiply by 2. And when we create a stack frame, there are a few things to remember. This stack frame is a solid box. We can't escape this stack frame. As long as this stack frame is on the stack, whenever we're inside this stack frame, we cannot access any of the variables that are outside of this stack frame. So inside this, we create it. We create the stack frame. We label it with the name of the method that's being called. We create a return arrow. This method call is going to return. When it returns, it's going to be reassigned to the value, or x is going to be reassigned the value that this returns. So we're going to create a return arrow to the value x to show where that value is going to end up going. And then we take the parameters, which is only one in this case. Oops, I can't highlight it. Which is only one in this case. We take the parameters and assign them to the arguments. So the parameter name input, and the value is going to be whatever the argument resolves to. So the argument is an expression, which is a variable, in this case, the variable x. And we want to look up what x is. So x, and here's the first time I'm going to recommend this. I'll recommend this a lot. To find out the value of x when you're doing a trace, I wouldn't look at the code. Don't look at the code. If you look at the code, you're going to be, some percentage of the time, you're going to accidentally put 4.0 for the value of x instead of 1.2 because it was reassigned. Instead, look at your memory diagram. Do exactly what the computer is going to do in this situation. The computer will not rerun all of your code to figure out what the value of x is. The computer is going to go to its stack, which is the lookup table, and look up the value, the name x, maps to the value 1.2, and now you're not making the mistake of choosing 4.0. You're always going to do 1.2 here, as long as you didn't make a mistake somewhere else with the reassignment. You're going to get the actual latest value, current value of x, and use that value. So I would treat this as though you are the computer, going line by line and just very simply doing every basic step. One of the traps students fall into is overthinking the memory diagrams, or thinking too much like a human. I know this sounds really weird, but thinking too much like a human and trying to reason about what the code is trying to do, and then trying to get the trace to match what you think the code is supposed to be doing. I wouldn't fall into that trap. Just go line by line and just very basically, a computer can do this stuff and it has no intelligence at all. Just kind of turn your brain off a little bit and go line by line. Multiply by 2 takes x. What's x? I don't know. What's next to x? 1.2. That's what x is. That's what's passed to input. That's what's passed into the method. Okay, so we have our return arrow, the name of our method, parameters assigned to the arguments. Now we're ready to run the code inside the code block. As we're running this inside the stack frame, as we're running the code inside this method call, we only have access to the stack frame. So the only variable that we have access to is input at this point. So none of these other variables, it's like they don't even exist while this method is being called. So we have a new variable declaration result. This is declared inside this method call, so it's declared inside this stack frame. Inside the stack frame, we have result, and it's going to be equal to input times 2. What's input? I don't know. I'm just going to look over here like a dumb computer would. Input, I can only have access to variables inside this stack frame. I find a variable named input as the value 1.2. So 1.2 times 2, 2.4. Then I'm going to return result. So I'm following my return arrow. Result is 2.4. follow my return arrow, x gets 2.4. I'm going to cross out the old value, put in 2.4, and then cross out my stack frame. Once a method call ends, we return result. That's the end of that method call. We go back to the main stack frame and delete this stack frame that we used for that method call. This means that input and result are no longer in memory at all. What the computer actually does is deletes this from memory. It's completely gone and inaccessible. Can never access those variables again. For our memory diagrams, we annotate that by crossing it out. That means this stack frame doesn't exist anymore. It returned, gave control back to the main stack frame, gave it that value that was assigned to x, and then the main stack frame can continue execution right here, where it's system.out.println x, which is 2.4, print 2.4, oops, 2.4. And then we move on with our program. Y of word, that's going to be a new stack frame. New stack frame, label it with the name of the method. We create a return arrow, but this is a return type void, so we'd have no return arrow. There's nowhere to return to. It takes word with the value of word, which is hello. And then we execute this stack frame. Now notice that I have, first of all, there's no reason for this parameter to exist. I don't use it anywhere. But just for the sake of example, that in a stack frame, once this code is executing in this method call, in this stack frame, I only have access to the variables inside the stack frame. So if I use the variable word, I will get this variable's value right here. I will not get this variable's value because this variable is out of scope. I cannot access this variable right now because I'm in a different stack frame. Each stack frame is a completely isolated environment. It's like a whole different program that's running just for that method call. And this method prints, why do I exist? And this is where we want to be consistent with our quotes. When you're printing to the screen, strings print without quotes. When they're stored in memory, they're stored with, well, at least we annotate them with the quotes. Part of this is the difference between like the Boolean true and the string hello. If I have the string that's true, if that's what I put in this variable, my quotes, that's what's going to tell me that that's a string and not the Boolean value true. So that's the reason why we have those quotes, if you're ever wondering. If you think that's just a nitpicky thing, it's so we can tell that this is a Boolean and this is a string. That stack frame ends. We have no return statement, so it ends when we get to the end of the method, the closing brace. Cross this out. That's the end of the main stack frame. Cross this out, and that's our finished memory diagram. So that's our trace of this code. So if you had this code on a quiz, which you wouldn't have this on a quiz because it doesn't test OOP or data structures, but if this were the quiz, you'd get this code, you'd generate this trace, and that would be a passing trace. Unless I made a terrible mistake that I didn't catch, but I'm pretty sure I did not. So that's what you're going to be asked to do on the quiz. You'll use the same tool. The code will already be there when you start the quiz, and then you'll trace that code. Control-Shift-P. Control-Shift-P. Okay. Will the main stack frame always get crossed out in the end? Yes. Why does word get assigned hello if it can't, if it cannot access the main method? So when it got the word, so when the argument resolved, I don't like that I can't highlight things. The argument, but I do want that behavior. It's the expected behavior. I just got to get used to it. When the argument resolved, we were in the main stack frame. So when the argument word resolved, we had access to this word. That resolved to the value hello. So this passed the value hello over to this variable named word. And I purposely named them the same thing to show that we can reuse variable names like this. So this So this parameter got the value hello from the main stack frame, passed it into the new stack frame, and that's where this hello came from for this copy, for this variable named word. So that's how, because stack frames are isolated, closed off environments, the parameters, passing arguments to parameters, that's how we communicate to stack frames. And then we communicate from stack frames through return values. So parameters and return values, that's how we communicate across stack frames. At least until we start using the heap. Then we'll have a new tool in our arsenal. Control-Shift-B. All right. Okay. So, and I think that got us through all of the slide content. Hopefully I didn't miss anything, because that would mess up my whole timing. Okay. Yep. All right. And we are exactly on time. 12:40. That's exactly where we should be 2 lectures in. Okay. Hour 5 of lecturing today. I can do this. And I think... yeah. I think I can do this. I might not even open the slides. So I think that went well. I nailed my timing on it too. I might try to keep going this way of borrowing Paul's style of lecturing. So I'll do my style for the 8 a.m. and Paul's for the 11 p.m. Unless something starts going horribly wrong. I think that's going to be my plan. Plus, that's more fun. Doing the same exact lecture twice in a row is just absolutely boring to me. And I give you all more variety of teaching methods. I think it could be perfect. Oh. Okay. So we got 2 examples to do, this plus minus and loops. So let's get rid of them. Plus I get to vary my examples a little bit on the fly, which is always fun. Especially when you have questions and I can just adjust on the fly and just change the code to answer your question. Okay. Conditionals. Of course, the code's going to be a little bit mismatched from the slides, but you'll still have the VODs to look through. Can we import the code every week from the repo too? Right. I'm not... I'll have to think about this. When I'm doing the live coding like this, I don't intend to push the code. It's going to be almost the same as what's in the repo. But you do have access, like all of this code that you see, all of this is in the repo linked at the top of the course website. You can look at all of this stuff right now, right today. Okay, so we want... but when I do this live, like I'm gonna not memorize every variable name, for example. So there's gonna be some differences. Okay, conditionals. So this was public. Everything's gonna be public static. This is going to return a string for your letter grade. String. The method was called letter. I remember that one because we had a whole bunch of stack frames. And it's going to take your score as an integer. And what we want to do is return your actual letter grade. And I'm going to show something that's going to come up in testing. I'm going to do this right now. I want to create my main method and get the structure of my program all set up. For starting on Tuesday, this will be our testing. We want to get all of our testing set up before we write our code. It's usually nice to have the tests there before you have the code all complete. So what we'll do is what is called stubbing out the method. I'm just going to return anything, just something, so that this compiles. If I have no return statement, if I have no return statement at all, I'm going to get errors, and I can't run anything. So I just have some return statement that satisfies my contract, just so my code compiles. And then I can set up my main method. Int score equals 98. I was like, how is this set up in the slides? I did remember, but I want to do it a different way anyway. Grade equals letter of score. Score equals 74. Grade equals letter, and I'm not redeclaring, so I don't specify the type again. And then score equals 31. Grade equals that. S out. So I want to call my method 3 separate times. I'm going to print out my grade after each call. And that should be my whole main method. So I want some method that's going to tell me my letter grade, and we're going to say anything in the 90s is an A, 80s is a B, 70s is a C, 60s is a D, and below 60 is an F. So this should print A, C, F. That's my goal of the method that I'm going to write. And let's see how we're going to accomplish that. Oh, yep, here's our first problem with live coding. I completely forgot one of the things. I completely forgot to talk about integer division. But that's fine because we're going to talk about it right now then. Let's do it right here. Int x equals 6. I'll use the same numbers as I used before. And s out x. What would we expect to be printed with x? And I'm not going to wait for the 10-second delay. I'll just give you the answer. It is not 1.5. This is going to be 1. Once we wait for it to compile. So this is going to print 1 to the screen. This is what's called integer division. So whenever you have two integers divided by each other, when I have an integer divided by an integer, that's always going to give me a result that is an integer. So 6 is an integer divided by 4. The result has to be an integer. So we would get 1.5, but since the result has to be an integer, what Java will do is delete the 0.5. It'll completely truncate the decimal portion and give us just the whole number value. And it'll effectively take the floor of the quotient. So 6 over 4, we completely lose the 0.5, and we get just the 1. Even if the result is almost the next whole number, so this is 0.99, we're almost at 1, but it's still going to be 0 because it's always the floor. It completely truncates the decimal and gives you just the whole number portion. So 0.99, you just get the 0. And this doesn't even matter if you store this in a double. This what came up in the previous lecture. Even if I store this in a double, I'm still going to get integer division. So this is going to be integer division. Everything on the right-hand side is evaluated. That's integer division. So it's two integers divided by each other. That's going to result in an integer that's going to be 0. And then when the assignment happens, Java's going to see, oh, this variable is of type double and I have an int. Let me convert this int to a double for you and convert 0 to 0.0. So even if you're storing it in a double, that's not going to work for you. If either one of the operands is a double, then you avoid integer division. So if I do 99.0, for example, now I don't have integer division anymore. I have floating point division, and now I get my 0.99. So two ints divided by each other will always result in an int, which will be the floor of the quotient. That'll come up a few times, including right now. So I'm going to create an int tens, and what I want to do is get just the tens value of this score. So score divided by 10 is going to give me whatever's in the tens position here, assuming the score is a 2-digit number. Since this will be divided by 10, but with integer division, it's only going to give me the whole number. So when it's 98 divided by 10, instead of 9.8, I get just 9. So the tens is going to be just the tens digit. This is going to come up in your task 1. The second out of 3 methods you have to write and test and write is going to be sum of digits. given an integer, return the sum of the digits of that integer. And it can be any arbitrary integer. This is part of that puzzle. If you use dividing by 10, what this effectively does is erases the ones digit and moves all the other digits to the right by 1. And if you use the modulo operator, like if I wanted the ones digit, I would take score modulo 10, and that's going to give me just the ones digit. So if you combine these two in a loop, you get just the ones digit, and then erase the ones digit and move everything down, get just the ones digit again, and keep summing those up, then you can get the sum of the digits. Not to spell out the solution exactly, but I kind of just did, which is fine. I did in the other lecture too. It's planned. And I like pointing that out because a lot of the lecture examples are designed to show you how to do the homework, and students don't always make the connection, and then they yell at me because I didn't show them how to do the homework. I want to make the connections clear when I can that this example and when we do plus and minuses next Tuesday, those two examples combined are showing you how to do the sum of digits, giving you the tools that you need to be successful with sum of digits, and then taking those tools and combining them in a new way, which is what we assess with programming. Can you take the tools we showed you and apply them to new problems that we did not show you? And that's a lot of the goal of programming. We arm you with the tools to succeed in the future, no matter what problem life throws at you down the road. Okay, so we have the tens digit, and the whole point of this one is to talk about conditionals, and I don't really have much to talk about with conditionals, surprisingly, that you haven't covered in 115. So conditionals in Java, they're regular conditionals. If some Boolean expression, if tens greater than equal to 9, return A. Else if tens greater than equal to 8, and I'm going to write this in kind of a weird way. This isn't necessarily how I would write the method. It's close though, I guess. But I'm going to do it in a way that's going to set up the talking points that I want to say in the memory diagram, specifically with this one right here. Else if tens greater than equal to 7, string result equals C, return C. Else if tens greater than equal to 6, return D. Else return F. So it's a conditional. You've seen conditionals before. Indentation and white space do not matter in Java at all. So we need our code blocks, our braces, to indicate when a code block starts and ends. Other than that, you know conditionals. No matter what language you're coming from, you know conditionals. You've seen them. If the difference between if, and else, you should all be familiar with that. A few things I want to point out Java specific is, or not even Java specific, but strong typing specific. I have a contract with Java to return a string. I must fulfill that contract. And I must fulfill that contract no matter what path I take through my code. So Java's going to make sure, if I have a conditional here, that no matter what path I take through this conditional, it's going to make sure that I return a string. So for example, if I return a string, return a string, return a string, return a string, but right here I don't return a string, now Java's going to yell at me at the end of this method. It's going to say, I expected you to return a string and you didn't. You didn't fulfill your contract. And it says the error is missing return statement, which is really frustrating because I have 4 return statements. I have 4 return statements. How could I be missing a return statement? And it's because if this is false and then this expression is true, I have no return statement here. Now I can fix that by adding a return statement down here. If I had my default return statement still, then I catch that. But in any case, I need a return statement for any path through this code, or Java will say, you told me you return a string and you did not. You didn't do what you're supposed to do. So we have to make sure every condition returns, or what we could do which I might, actually I think I might set this up this way, is string result equals empty string, just some default. Result equals result equals I don't know. I just needed some name for that. And then at the end, return result. This is more of the structure I like. I don't like all those return statements in the middle of my method. But something like this, we could set it up this way. I think I will leave it set up that way because it makes the memory diagram more interesting. Okay. So that's conditionals in Java. Let's trace this thing. Why do I have so many ads on here? I gotta set up this machine again. And I pop that out. So I gotta zoom in like this. Right? And then paste it. Then zoom out like this. Is that my hack? Is that really what I gotta do? Or am I just missing the right pixel? Let's zoom in a little bit here. We still won't need heap. Okay. And how's my timing till 1:30? Okay, we have some time, but not a ton of time. But we should be good for timing. I want to show some things in IntelliJ too, so hopefully we have a little bit extra here. So main stack frame, score 98, and then we have a method call grade. Now this is a new situation, old if you've taken 115 with traces. We have a variable being declared and then being assigned the result of a stack frame. When we have this situation, what we'll do is put the variable on the stack with no value, just so we have some place for the stack frame to return to. So we have some place for this arrow to point to, and we don't have to remember where we're returning this. When we hit a return statement, we just follow the arrow. We can think very little and just follow the arrow to where it goes. Label this as the name of the method. And it gets score. So score, which I purposely reused the variable name to show that we can have the same variable name as long as they're in different stack frames, is an important part of stack frames. Since they're isolated environments and we can't access variables outside of the frame anyway, doesn't matter if we reuse variable names, which is really handy. If that was not the case, when you call, like when you have math.pow, and if that uses x and y as variables in that stack frame, now if you want to call math.pow, nowhere in your code can you use the variables x and y. It'd be really frustrating knowing for every library that you call, for every method that you call, you have to know every variable name that they all use and then avoid all those names. Boy, would that be frustrating. So it's very handy that stack frames do allow us to reuse variable names, or else programming would be a lot more tedious. All right, so letter gets score. Tens is score divided by 10. So that's going to be integer division. Tens gets the value 9. We have a string result, which gets empty string. And then if 10 is greater than or equal to 9, which is true, result equals A. So we're going to cross this out. Whenever we have a reassignment, we cross it out and write the new value. Even if the old value was empty string, we're still putting empty string and crossing it out. Even if an int gets initialized to 0 and gets crossed out right away, we still cross it out. And then all the rest are else, 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 else if, else if, else if, else. So since this one was true, we ran this block and skipped all of the rest and go right to return result. So A gets returned. I forget where, but I got this return arrow that tells me it gets returned right here. A. cross out my stack frame, go back to the main method, and print grade. Print A. And then score equals 74. And do the same thing. Letter of score, create stack frame, letter, returns here to grade, score, which is 74. I'm not looking at the code to find what score is. I'm looking over here, so I don't have to remember anything or recompute anything. Tens equals score over 10. Integer division, so it's 7. Result is empty string. And then if 10's greater than equal to 9, false. Else if 10's greater than equal to 8, false. Else if 10's greater than equal to 7, true. So we hit this code block. And so you might be wondering, why did I put this string comp here? Why did I do it like this? And that's specifically so I can talk about what I'm about to talk about. This is something you wouldn't do this in your actual code. There's no reason to do this. But if you want to talk about a specific thing in lecture, that's when you would do it. So what I need here is a new code block. Every time you have a set of parentheses, that's a code block. For our purposes, that's going to be conditionals and loops. Those are going to be our sources of code blocks in this course. So whenever we have a variable declared in a code block, we have to treat that differently. We're going to create a code block in our memory diagram, which is going to be a dashed box. This dashed box means that I see this as semi-permeable. We're going to create variables inside the dashed box, but we still have access to the variables outside the dashed box, outside the code block, as long as those variables are in the same stack frame. We still can't access anything outside the stack frame, but we can access them outside the code block. So we create comp inside the code block, and it gets the value C. And then result equals C. We can still access result because it's in the same stack frame, even though it's outside of the code block. This gets the value C. Result equals C. And then when we hit the end of a code block, we cross out that code block. This means that any variable declared inside the code block cannot be accessed after we hit the end of the block. So comp, this variable, is no longer in memory. We cannot access it. It's like it never even existed. And that's why we have to create our code blocks, is to track which variables no longer exist after that code block ends. So comp doesn't exist, but we did get the result in this result variable, and we can return that. That's what we're going to end up returning. Skip all the else's. Return result. Cross this out. Result gets C. And then we can move on with the program. So that was right here. Print out C. Score equals 31. Cross out the old value, write in the new. Letter. We've done this dance a few times, so let's get our last letter. Mark is returning here. Score 31. Yes. Oh, yeah. Oh, I forgot to mention that with the other one. So with the first stack frame and the one that I'm doing right now, I'll explain it while I'm doing this one. And with this one right now, when we get into the code block, we don't declare any variables in that code block. So we don't have to trace that code block then if there's no variables declared in it. So at this point in this code, we got false, 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 and then we hit the else. We do have a code block here, so we could, and if you did this, that'd be fine, create a code block. But since that code block won't have anything in it, we'll create the code block. Result gets the value F, and then we cross out the code block. So we had a code block that doesn't have any variables declared in it. When that's the case, you don't even have to have the code block at all. There's no reason to. It didn't affect the memory diagram at all. It tells us that you knew that a loop occurred, that a code block did occur, but we'll give you the benefit of the doubt on that one. So for this first letter stack frame, we didn't have our empty code block. And I'm not going to have my empty code block here. Actually, I don't think we can delete code blocks. I don't think that feature exists quite yet. Oh, okay. I can just delete all the variables in it. So we don't have to put the code blocks if they're empty. And then this returns just like the first one. Cross out F. Then we hit the end of our main stack frame. So we cross out the main stack frame, and that's the end of our program. That's another memory diagram down. Any questions on this one? I think we've gone through enough content there. I'll wait a few seconds here for the stream delay. Let's see if y'all have questions about this. And I left the old memory diagram open too if you have questions on this one, anything, any which one. Before we get into loops. 25 minutes to go. We got this. Okay, I'm not super patient. I want to go to loops. But I'll keep watching for questions. If there are questions, I'll hop back to these ones. I'm not patient enough to wait out the stream delay. New class loops. And let's see a couple of loops. So I'm going to go in a main stack frame and create the notorious while loop. How did I set up this example? It was double number. Need to be able to create more interesting examples. Number. Boring. The while loop. A while loop, which you may or may not have seen. I forget if they're doing these in 115 these days or not. Is very similar in syntax to a conditional, except it's going to execute as long as the condition is true. So if I do while number greater than 1.0, no, I want to do this. Let's do 2.0. I do 1.0 and it's just too many iterations. It gets boring. So while number greater than 2.0, I'm going to print out the number and then divide the number by 2. I'm going to start using shorthand and tips and tricks and stuff like that in 116 that I wouldn't do in 115 because, well, second semester, you're ready for more tricks. I think you'll appreciate just seeing things like that. That said, I think they started showing this stuff in 115 anyway. At least plus equals you've seen in 115. If you haven't seen divide equals, it's the same thing. This is the equivalent of number equals number divided by 2. These two lines are equivalent. They do the same exact thing. The divide equals is just shorthand, so we don't have to type as many. We save some keystrokes. And as programmers, we appreciate that. We like being a bit lazier. So this is a while loop. This is going to execute while the condition is true. So number equals 10. 10 greater than 2 is going to be true. We execute what's in the code block for the loop. That's going to print 10 and then divide number by 2. So number is 5.0. 5.0 is greater than 2. So we execute the loop again. Number is going to be 2.5. 2.5 is greater than 2. Execute again. Number is going to be 1.25. That's not greater than 2. So the loop ends and goes on with the rest of the program. So while loop, it's like an if statement, but it keeps checking the conditional after each time it executes and will execute multiple times. And it's worth noting that your loop might never execute. If the condition is false when you get to the loop block might never execute. So don't rely on what's running in your loop to initialize some variables or anything, because that code might not execute any any times. It might not execute at all. There's no guarantee that it'll execute even one time. And that comes up sometimes. Just be careful the way you write your code. Don't assume the loop is going to execute at all. And then the for loop. For int x equals 0. I'm trying to do this. I'm trying to just make this up as I go along, but I remember the examples too well that it's hard to forget them. Except I think this was val instead of number. X less than 3. I am going to change the values because the memory diagram got a little tedious last time. And then x plus plus. So a for loop is made up of 3 separate parts. One, the initialization statement, which executes one time when we first get to the loop. Oops, I forgot I had these. When we first get to the loop, we're going to execute this code one time only. Then we're going to check the conditional, and this part is just like the while loop. If the condition is true, we're going to execute the code block, and each time we get to the end of the code block, we're going to execute the increment statement and then recheck the conditional. So we're going to, and I'm just going to s out x here. So we get to this loop, we initialize x to 0, we check if x is less than 3, which is true, execute the loop body. When we get to the end of the loop, we increment x, this x plus plus. In Python, this is the same as x plus equals 1, or which is also the same as x equals x plus 1. So we're incrementing x by 1. So x is going to be 1. 1 is less than 3, so we execute again. Increment to 2. 2 is less than 3. Execute again. Increment to 3. 3 less than 3 is false, so we are done with that loop and we move on with the program. One thing to note with the initialization statement is that the anything declared in the initialization statement is technically part of the code block for the loop. So when we're creating this code block, anything that's initialized here is inside that code block. It's inside the dashed box in your memory diagram, which means once you hit the end of the code block, then, I'll go back to the other example too and do this. Once we hit the end of the code block, x is destroyed with the end of the code block. So if I want to do s out x right here, I can't do that. And you're going to get this really frustrating error. Cannot resolve symbol x. And you're going to be driving, absolutely going crazy with this one because you're going to say x is right effing here. Like, how, computer, can you not find x when it's right there? It's right there. I know it's there. I can see it. You saw it. You ran my loop and everything. And then all of a sudden, you just have no memory of x. And yeah, that's what happens. You at the end of a code block, the computer forgets every single variable that was declared as part of that code block as if they'd never even existed. So when we try to print out x, the computer's just like, I don't know of any x. Do you know an x? I don't know an x. Even though it was just messing around with x, not 2 lines ago. Doesn't know about x because it's in a previous code block that was destroyed. That variable's gone. Just like here, this comp was declared. Once we hit the end of the code block, comp is destroyed. So if I try to s out comp here, I'm going to get the same issue. That variable doesn't exist. And here it's a little more clear that it doesn't exist because you would have to take this specific path through the code for that variable to ever be declared. So it's a little more clear why Java does this in this situation. But either way, whether it's declared or not, we get to this point and we can't access that variable because it was declared in a code block that has already ended. Okay, and we're ready for another memory diagram. No questions on the old ones. Okay, I gotta be doing something wrong with this. Maybe there's a magic pixel I can hit. Oh, yeah. I don't know why I had so much trouble in the earlier lecture. I take it all back. Okay, so let's trace this thing. We still don't need the heap, so I'm going to cover up the heap with my code. And make this a little bigger even. Okay, we start with the main method. It's the only method in this. We have no extra stack frames. So main number equals 10. And then while number greater than 2, that's true. We're going to print number. Number's value is 10.0. And then divide number by 2. Cross it out, divide it by 2. And then check the condition again. We get to the end of the while loop. Number greater than 2, number is 5.0. So that's true. So we're going to run around again. So print 5.0. Divide this by 2. Check the condition. 2.5 greater than 2 is true. So run it again. 2.5. Divide this by 2, 1.25. Check the condition again. 1.25 greater than 2.0 is false. So we skip to the end of the loop and move on with our program. Now, an important thing to note here, two things I want to point out. One, there were no variables declared as part of this while loop code block, so I don't have a code block for the while loop. Number was declared before the block started, so it's part of the main stack frame proper, not inside any code block. So number will live longer than the while loop. If I want to use number outside of this while loop or in the for loop even, number still exists, and that's perfectly valid to do. The other point is number does get the value 1.25. 1.25 is never printed to the screen, but number does get to the value 1.25 because it's divided by 2, it gets to 1.25, then checks the condition is false, and then never gets to print out 1.25, but it does get that value. And this is going to be very dependent on the code. If we say divided by 2 first and then printed to the screen, then it will print 1.25. But this is where I need you to not overthink the memory diagrams. Don't try to figure out what this is trying to do or anything. Just blindly go through one line at a time. If you do exactly what I just did and check the condition, be the computer, check the condition, run the code, check the condition, run the code, check the condition, run the code until the condition's false, then skip to the end. If you just blindly go through like that without even thinking about the code, just one line at a time, you'll get all of the little nuanced things like that. The fact that this is 1.25, but 1.25 is never printed, that is not something you need to memorize. And hell, on the quiz, we might give you a quiz where that's not the case, where I do switch those two lines if I give a similar example. The point is you should follow trace line by line and just not overthink it. I also, this is going to sound weird too, but I do see students overstudy for these. The number of times I get traces for a quiz that looks just like, or eerily similar to at least, the traces that we did in lecture, but completely ignore the code that was given on the quiz, where students try to study lecture and just regurgitate what we did in lecture on the traces. That is not a successful strategy on these quizzes. Go through learn how to read code. That is what we're assessing, is your ability to read code. Learn how to read code and just read the code one line at a time. Take it slow, double check your work, and don't overthink it. Don't overthink it, don't overstudy. I know that can sound weird. It's weird advice, but I think it is good advice, sound advice. Okay, now when we get to the for loop, a very similar thing, except X is declared as part of the loop. Initialization statements are declared as part of the loop code block. So I need myself a code block here. I'm going to create X inside the code block with the value 0. Check the condition. 0 less than 3 is true, so print out 0. And then we get to the end of the code block. We run our increment statement, cross out 0 and put 1. 1 less than 3 is true, so we execute the block again. Prints 1. Get to the end, increment 2. 2 less than 3 is true, print 2. Get to the end, increment to 3. Now X gets the value of 3. 3 less than 3 is false, so we end the loop. We go to the end of the loop, cross this out. X is no longer in memory, That's why we can't print x after this loop, but we could print number. That would be perfectly fine. But notice again, x got to the value 3. It was incremented to 3 to the value that makes this condition false, but the loop never executes while x has that value. So x has the value 3. That's its final value as it leaves memory, as it gets erased. But 3 was never printed to the screen because the loop never executed when x had the value that broke the loop. So again, a little nuanced point, but if you're tracing the code one step at a time, one line at a time, you'll always catch those. It should be automatic. You should have an approach to these that makes that automatic. Okay, if there are questions, I'll be watching chat to see the questions come in. Oh, that's 1-1. Let me just make sure I didn't. Oh, I closed the slides entirely. Let me make sure I didn't make a big oopsie here. Did we get everything? Yeah, it was just those two examples. Cool. Okay, so I'll watch chat if there are questions, but I want to hop over to IntelliJ. And yeah, my timing's spot on with these. It takes just about as long as going through the slides. So I guess that is. I always wondered how Paul got through his lectures doing all that. It seems like so much more like time spent just typing, but it actually went pretty well. What am I doing? This. So this is something we usually do in lab, but we don't have lab, so I got to do it here. If we go to the examples repo and copy this link, we go to the code and copy that. I want to show you how to get this code in IntelliJ. So once you download IntelliJ, install everything, what you'll do is find the Git icon, and I can't figure out how to get back to the main screen when I close this. It just shuts down the whole thing on Windows. It's not like that on Mac. Anyway, but somewhere you'll find Git or version control, VCS for version control software. Somehow you're gonna see some option like that, and they keep changing the interface, much to my frustration. So I can't just say this is where it will be. But in my menu, it's Git and then clone, and then paste that link. I have to change this directory name just because I've cloned this a bunch of times. I have to use a directory that hasn't been used yet. But you can keep the same directory name and click clone. Oh, that one's not empty either. Clone. And that's going to download all of that code onto my machine and set up the whole project for me. And everything should be automatic the way we have things set up. It should download all the code. You can see the source directory, all of the weeks of content, all for the entire semester, including some weeks that we won't cover in the summer. We'll do up to graphs with the weeks. A few of these weeks won't even be used. I'll have to note that in lecture when we're skipping some of these weeks. And you have all the code. You can run this code. Oh, I was hoping it wouldn't run so I could show you how to set the rest of it up. So I'll have to break it so I can fix it. So you might get this JDK not defined. If you do setup SDK, download JDK, and then choose whatever the default option is. Right now it's Oracle JDK 22. Download that, and then that should get rid of all your errors, and you'll be set up. Looks like I got another one. So I'm going to do configure and select that JDK that I just downloaded. Maybe if I was patient and waited long enough, that would have just went away on its own, possibly. Maybe I'll have to be a little patient right now. I must have broke it more than I expected to. Then your program can run. Hello, Java. So that's how you can get the code set up in IntelliJ once you download it. And then it's the same idea for the homework. So when you're ready to start programming task 1, go to the handout. The first thing is the GitHub link. Copy the link for the code. Go into your IntelliJ, git clone, paste. I'm sure I have this clone too. Clone, and then that'll give you the starter code for the project. Oh, I have Java 20 in the setup. Oh, is this gonna cause issues? Oh, I hope not. What do I have in? Oh, it didn't have issues here, and I have 21. Ugh, I have different versions here. If it does start complaining that you have a different version of Java between 20, 21, 22, if you go to this pom.xml and change this to whatever version of Java you're using, that might get rid of your whatever issues you may see there. But, well, let's see if there will be an issue. So we're using 22 here. Just run an empty main and see if it'll run. Yeah, allow access to Java. Yeah, it worked fine. Okay. So hopefully that won't be any issue at all. But once you clone this will give you the start to the project. This data structures directory you do not have to worry about yet. All 8 tasks will use the same project. So some of this stuff is set up for later tasks. Data structures you don't have to worry about. Problem set and test problem set is what you'll use for task 1. And writing the problem set code, for the most part, especially after Thursday's lecture, you'll be able to write all of the code for task 1. But you don't necessarily know how to do the testing yet. Unless you watch old lectures from previous semesters, you'll be able to do the tests. Or if you mess around with the examples repo, for week 3 and go to any of these test files, you can see the basic structure of how to set up tests here. But it'll make a lot more sense when we get to the lectures on testing. So, holy crap, with Paul's method, I got through everything I ever dreamt of saying with 4 minutes to go. Holy shit. So, if anybody has questions, we actually have time for a few questions after getting through all these memory diagrams and live coding. Okay, Paul, I might turn over to the dark side just a little bit. Not all the way. I did try his style in a live lecture. Maybe I just can't do it right next to the keyboard. Maybe that keeps me on track. If no one has questions, I might even just end the stream 2 minutes early. Instead of just sitting here staring at my computer. Yeah, so I'll have, let me see if I'm logged into Piazza, if I remember my stuff. I should remember this one. So I'll have office hours starting at 2. I gotta get something to eat, and then I'll be in there for an hour. Question. I don't know if that's a question. So I'll have office hours. I don't know if anyone will have questions quite yet, but I'll be there. I'll be in the Zoom meeting for an hour today, and then I'll see you on Thursday. Are there any resources that you know of to give examples with correct tracing so we can test ourselves for practice? So there are the lecture examples is the main source for that. But outside of that, we don't really have more resources. It's something we get asked a lot that I do want a better answer for. But for the summer, we're not gonna. But if you do So any code, the one thing about traces is, if you have any code ever, you can trace it. So if you have code, any code that you have for your homework, lecture examples that we don't do traces for, or just any code that you've written for any reason, code that you find online, any piece of code can turn into a trace. You can just trace that code for practice. You won't have the correct solution, but if you come to office, I'll tie this into what I'm saying too. If you come to office hours with, hey, I did this code, I went to the practice thing, share your screen, show your memory diagram, I would always be happy, me and the TAs would be happy to go through your trace and give you feedback on it. So that would be one option for you. But as far as just a bank of solved traces, unfortunately doesn't, I won't say it doesn't exist, it's just that they're all lecture examples. Whenever we create one of those, we make it a lecture example. Okay, yeah, I'll be in office hours shortly. Gerline doesn't have her office hours on here yet. What the hell? I'll have to go yell at her to get her office hours on here. And if you don't come to office hours, I'll see you on Thursday. Take care, everyone.